In this video, I'm going to explain rational exponents and how to solve equations with rational exponents. So we have 7 to the exponent 1/3. Our base is 7, and our rational exponent here is 1/3. So a rational exponent is an exponent that can be expressed as a fraction. I'm going to erase the 3 and put it in a different color, the denominator, and then I'm going to erase the 1 and I'm going to put that one in a different color. So when converting it from a rational exponent into a radical, we're going to put the base underneath the radical, the denominator of the rational exponent, the 3, on the outside of the radical, and then we can put the exponent, the numerator of the rational exponent, as the exponent of the radical. So that's how to convert a rational exponent to a radical. If we had the base of 3 and the numerator of 5 and the denominator of 2, and converting it into a radical, we can put the radical here, our base inside of the radical, the denominator on the outside of the radical, and then the numerator as the exponent. Now, you can also write this as radical 3 to the 5th. Because if there is no exponent here, if there is no number outside the radical here, it's an invisible 2. So both of these are the same. And then converting it from a radical to a rational exponent is just the opposite. So I'm going to do 2 examples here. If we have radical 3 here, it's called the 4th root. The 4th root raised to the exponent 5. This is going to equal our base of 3. Our numerator is going to be 5, and our denominator is going to be 4. So that's just converting it the opposite way. So if we want to convert the radical, if it's this, and we want to convert it to radical 5, we want to convert it to a rational exponent. Our base here is 5. There is no number on the outside of the radical, so it's an invisible 2. So that 2 will go in the denominator of the rational exponent. And then there is no exponent here, so it's an invisible 1, and that will go here. Okay. So the square root of 5 is the same thing as saying 5, the base 5, to the rational exponent 1/2. So that's how to convert them from the rational exponent to radical, and radical to the rational exponent. Now we're going to go over how to simplify rational exponents. So let's say our base is 16, and then our rational exponent is 3 divided by 4. So the denominator is how many parts. So I'm going to write that down, the number of parts. And then this numerator 3 is how many of those parts you choose. So I'll just put choose here and put a line right above here. Green line means we're separating it. So we want 4 parts. 1, 2, 3, 4. And these 4 parts are going to equal 16. The product of these 4 parts are going to equal 16. And what goes, it has to be the same number that goes on the line. So what number, when multiplied by itself 4 times, gives you 16? It's 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Out of those 4 parts, we're choosing 3. So that means we're going to multiply 3 of the 2's together. So we're going to multiply just these ones. 2 times 2 times 2 is 8. So 16 to the exponent 3/4 is equal to 8. So that would be your answer. So let's try this one. The base is 36 and the exponent is 3 divided by 2. So we have 2 parts, so 1, 2. And those 2 parts, the product of those 2 parts are going to equal 36. So what number when multiplied by itself 2 times will give us 36? That's 6. And how many of those 6's are we going to choose to multiply together? 3. But there's only 2, so you just multiply just one more. 6 times 6 times 6. 6 times 6 is 36. 36 times 6 is 216. So 36 to the exponent 3/2 is equal to 216. Let's look at 100,000 b to the 10th to the exponent 3/5. Because of the exponent rules, we have to distribute the exponent 3/5 to the coefficient to 100,000 and b to the 10th. So we have to do 100,000, 5 parts. 1, 2, 3, 4, 5. The product of those 5 parts, product means that you multiply those numbers together. The product of those 5 parts have to equal 100,000. And then the product of the 5 parts also have to equal b to the 10th. So what number multiplied by itself will give us 100,000? It's 10. And what term multiplied by itself will give us b to the 10th? And that's b squared. B squared times b squared is b to the 4th, times b squared is b to the 6th, times b squared is b to the 8th, times b squared is b to the 10th. Because remember, if you're multiplying terms with the same base, you're going to add the exponents. So the same base is b, they have the same base, you're going to add the exponents. 2 plus 2 plus 2 plus 2 plus 2. Out of those 5 parts, on each one we're going to take 3. So 10 times 10 times 10 is 100,000. Sorry, is 1,000. And b squared times b squared times b squared is b to the 6th. So 100,000 b to the 10th to the exponent 3/5 is 1,000 b to the 6th. Let's look at one that has a negative rational exponent. If the rational exponent is negative, then we're going to put that base and the rational exponent underneath 1. So we're going to do 1 over. So you're always going to do 1 divided by, and then you're going to put the base 49 on the bottom. and the rational exponent on top. But the rational exponent now becomes positive. So now we're going to simplify 49 to the exponent 3 halves. So we have two parts that multiply together to the product is 49, and out of those two parts, 7 times 7 is 49. Out of those, how many do we choose? We choose 3, so it's going to be 7 times 7 times 7, so 49 times 7 is 343. So this is going to equal 1 divided by 343. So that's our answer here. So again, whenever you have a rational exponent that's negative, it's like this, right? 49 to the exponent negative 3 halves is the same thing as 49 to the exponent negative 3 halves over 1. So you take the reciprocal. Sorry, you're not going to take it. You're going to do 1 over the base times the positive rational exponent. Right now we're going to solve equations that have rational exponents. So in this case, what you want to do is you want to get rid of the rational exponent that on the side that has the variable. So we're going to multiply that rational exponent by its reciprocal or its inverse. So 3 halves times 2/3. And what that does is when you multiply those two together, 3 halves times 2/3, you should get 1. So you're just x to the first, or just x. But you have to do that to both sides. You have to do 343 to the exponent 2/3 as well. And then you simplify 343 to the 2/3. You have 3 parts where their products equal 343. So that's 7 again. And then out of these 3 parts, you're going to choose 2 of the parts. So 7 times 7 is 49. So that would be your solution for this equation with the rational exponent. For this one, we want to get the base b plus 10 to the rational exponent 3 halves isolated on the right side of the equation. So first we're going to add 7 to both sides of the equation, and we're left with 250 equals 2 times the base b plus 10 to the exponent 3 halves. Then since it's 2 times the quantity b plus 10, we're going to do the inverse of multiplication, and we're going to divide by 2 to both sides of the equation. So we were left with 125 times equals b plus 10 to the exponent 3 halves. So now it's just like the last problem. We have our base, which includes the variable b, isolated with the rational exponent. At this point, we're going to multiply by the inverse or reciprocal of 3 halves, which is 2/3, and we're going to do that to both sides of the equation. So we're left with just b plus 10 here, and now we have to simplify 125 to the exponent 2/3. So we have 3 parts where their products, those 3 parts product equals 125. So what number when multiplied by itself 3 times is 125? That's 5. So 5 times 5 times 5. And then out of those 3 5s, we're going to choose 2. So 5 times 5 is 25. Subtract 10 from both sides, and it's going to be equal to 15 as our solution.